Welcome to Grateful, where we tutor students all around the world in SAT, ACT, and PSAT. Right now, we're working on April 2021, Section 4, Calculator Math. And let's go ahead and jump right in. Question number 1 is a nice basic word problem. And if you are confused on one of these things, what you want to do is describe your variables. And it's amazing how much that can help you. Here, we're being told that D is the number of days that she rented the van, and we're being told that M is the number of miles that she drove the van. So now we just have to kind of figure out where the 3 goes. That's the number of days she rented the van, which is D. So all of this is to just tell us that D equals 3. So let's plug that in. 20 times 3 plus 0.7m equals 235. And just go ahead and simplify. 20 times 3 is 60, plus 0.7m is 235. Take away 60 from both sides, and we'll get 175. Divide both sides by 0.7, and we'll have m equals 250, which is B for question number 1. On to question number 2. Here, for this simple system, we're being told that x is 3, so we can use substitution. If we know that x is 3, we can just go ahead and replace every x with the number 3. So that gives us 3 plus 3 here for y. So all we did is we took this x and replaced it with the number 3. That gives us y equals 6, and we now know that x is 3 when y is 6, which is A for number 2. Number 3 is very similar to number 1. It's a word problem that's being presented in a very confusing manner, and the way around that is to describe your variables. Here we're being told that x is the number of days after November 1st. And later we're being asked about what happens 6 days after November 1st. So simply put, that's the idea that x is 6. So we're just going to go ahead and plug 6 in for x, f of 6. And that's negative 0.5 times 6 plus 56. And so this right here is negative 1/2 times 6. And half of 6 is 3, so negative 1/2 times 6 is negative 3. So we have negative 3 plus 56. And that's 53. D for number 3. Question number 4 here is giving us a table of x and f of x values. It's a little hard to understand here, so I'll just kind of recopy it. For the x's, we have negative 2, negative 1, 0, and 1. And for the f of x's, which are the y's, we'll have 0, 0, negative 2, and 0. And this may seem confusing at first glance until you realize that an x-intercept is the moment where y equals 0. And by the way, a y-intercept is where x is 0. So here we have a bunch of moments where y is 0 because f of x is y. So what we know right now are the zeros. We know that this thing has zeros at negative 2, at negative 1, and at 1. So it's got 3 zeros. And we also know that the y-intercept, the place where x is 0, that's negative 2. So we have this point right here as the y-intercept. And so from there, you can kind of fill in the rest of everything. It should look at least like that. And so if we're looking for the graph that has zeros just at negative 2 and negative 1, at those 2 green points, we can easily see that that's answer choice C. It's got the zeros at negative 2 and negative 1 right there. It's also got the 0 at 1. It's also got the y-intercept at negative 2. And so the answer for number 4 is C. Now we're going to question 5. What percent of 40 is 15? And this is one of the most awesome things about math, which is the idea that a verbal statement can turn into an equation. So right here we have some unknown percent. Of is the idea of multiplication. And then we have 40. And of course, is the equal sign. And that is equal to 15. So we've got everything we need right there, a nice equation that we can solve. So simplifying the 40 on the top and 100 on the bottom, That's 40 over 100, which is the same as 4 over 10, which is also the same as 2 over 5. So we can rewrite this as 2/5 x equals 15. Now, for anyone who didn't get what I just did there, it's really important to be able to see this as equivalent to this. And that's because any number, including 40, is really itself over 1. But realizing that helps you realize that we've got one number on the top, one number on the bottom, and so that's the fraction 40 over 100 that can also be simplified to 2 over 5. So to solve from here, we can just multiply by the reciprocal, 5 over 2, and that allows the 2's to cancel and the 5's to cancel, giving us x equals 15 times 5 is 75. Divide that by 2, and you have 37.5, and we now know that the unknown percent is 37.5%. Question number 6 has the sound of a proportion. If a car uses 27 pints of fuel for 63 miles traveled, then it's going to use how many pints of fuel for 7 miles traveled? And now we can just start simplifying through. I would suggest cross-multiplying this, and with a calculator there's no reason that you can't do that. But for me personally, I like the idea of multiplying by 7 here, so that right here we can simplify 7 on the top and 63 on the bottom. 63 divided by 7 is 9, and that becomes a 1. And now we can simplify the 27 and the 9 all together. And the advantage of this is, every time you go over to your calculator to calculate something, there's always the risk that you can hit a wrong button or mess up in one way or another. But if you just simplify things in a way that makes sense to you, so here 27 over 9 becomes 3 over 1, you can really avoid a lot of mistakes. So all of this is telling us that x equals 3, which is D for number 6. So for number 7, it appears that part of the description got cut off, so I'm imagining that says cup right there. And we'll find out if we're right based on our answer. But we have 40 cups, and as we said before, that's the same as 40 cups over 1. And if 8 fluid ounces is the same as 1 cup, that means we can multiply anything we want by 8 fluid ounces over 1 cup, or by 1 cup over 8 fluid ounces. Because if both of those things are equal to one another, then having a fraction with one on the top and one on the bottom is nothing more than the number 1. So for us, we're going to want cups on the bottom, 1 cup. I guess it's not plural then, huh? And we get 8 fluid ounces on the top. And so now cups can cancel with cups, and this tells us that what we should be doing is multiplying. 40 times 8, which is 320 fluid ounces, and the answer for number 7 is D. Going to question number 8, we're being told that we're choosing a red tree from the sample, and that's really important because we know there are 13 trees in the sample, and from those 13, we need to find one that has a diameter greater than 30. So how many are there that are greater than 30? In other words, that are on the right-hand side of that line. 1, 2, 3, 4, 5, 6, 7. So 7 out of 13. And the answer for number 8 is C. Now we're on number 9. For how many of the trees in the sample is the number of growth rings greater than the number predicted by the line of best fit? So we're being asked about the number of times that the actual values, the points, are above the line. So how many points are above the line? Let's count them. 1, 2, 3, 4, 5, 6, and I count 2 that seem to be like right on the line. But 8 is not an option, so we know 6 is the right answer, and that's C for number 9. Question number 10 is one of the many questions where the given units are actually your instructions, and a lot of people don't realize that. Here, we're being asked to take the number of grams and put them over the number of cubic centimeters. Well, the number of grams is 18.5, and the number of cubic centimeters is 2.5, and so now all we have to do is just divide those two numbers. and we get 7.4, which is B for number 10. So in question 11, we're hearing that these are 10 scores and that there's an 11th score that's an 18. So one that's much bigger than the rest. How's that going to affect the mean? The SAT definitely likes asking about what happens to the mean when a new number is thrown in. And just imagine you're in a class where the average score is 5, and suddenly someone comes in who has a score of 18. That's definitely going to boost the average in a higher direction, because the average, the mean, in general, is the sum over the number of values. So if I add in another value that's really big, it's going to push the average way up. So the mean will definitely be increasing, and that narrows out C, because C is the only one that says that the mean is not changing. Now what happens to the median? Well, let's highlight in blue right here. This blue group represents the group before the 18 was thrown in there, and to find the median, we would just count our way in. So count from the smallest values upward, 1, 2, 3, 4. From the largest values downward, 1, 2, 3, 4. And we have two values in the middle, and they're both 5s. So if you have two middle numbers, the median would be the average of those two numbers, which in this case, it's easy to tell that it was a 5. So our before median is the number 5. And now let's color all of these numbers to represent the idea that we're finding the median now with this new group, with the same numbers, but with the 18 being included in now. So if we count from the bottom upward, 1, 2, 3, 4, 5, and from the top downward, 1, 2, 3, 4, 5, and guess what? We land on the number 5 yet again. So before the median was 5, and after the median remains 5. So the mean increased, as we said before, but the median, as we just saw, remained unchanged. So the answer for 11 is A. On number 12, we're being asked for an equation of a line of best fit. And so we can kind of see that the y-intercept of this line of best fit could be somewhere around 10 or 15. One thing to notice is that all of the answer choices are in more of a b plus mx format, which, that's just enough to take the mx plus b and kind of confuse us if we're not aware of the difference. It's the same thing, just in a different order. But if our y-intercept is this number, we're looking for the y-intercept in the beginning. So we know it could be A or B because they have a positive y-intercept, whereas C and D have no y-intercept at all. And we also know that the slope is positive. And because it's in a b plus mx format, we're looking right here for the m for the slope. So out of the two remaining answer choices, only one of them even has a positive slope. So that makes our job easy, and the answer for 12 is A. So in question 13, we've got triangle, let's just say ABC like that, and DEF like that. If we're considering the idea that they're similar, then we're going to want the same order. So ABC like that, and DEF like that. They both have one angle measuring 40. Let's just imagine it's that top one. So we'll call this 40 degrees right here. And what else do we need to know these are similar? Well, what's the definition of similar first and foremost? It means that two figures have the same shape but different sizes. And what does it mean to have the same shape? That's the idea that the angles are the same. So we have one pair of angles being the same. It would be awful nice to have one more pair of angles. And the reason is, let's just say, for instance, that these angles are both 50 degrees. Because the angles of a triangle add up to 180, that means that by default, this would have to be a 90-degree angle, because we need both of these to add up to 180. The point is that if you have two pairs of matching angles for a set of triangles, then the third pair of matching angles will automatically be the same, as we saw here. We got 90 for both of these. And so that's why the answer for number 13 is C. To know if they're similar, all we need is the measure of another pair of corresponding angles in the two triangles. If they matched up, then we know that the triangles would be similar. If they didn't match up, then the triangles would not be similar. But in any case, the answer for 13 is C. Question 14 is a corralling question where the SAT is not just necessarily trying to make you get it wrong, they're trying to get you to waste some time here. So how can we get from what we're given in blue to what we're looking for in orange with the least amount of effort? And so just little by little we could maybe take away that 1 from both sides, and that would give us 3 x over 5 plus 1/2 equals 9. And what's the difference between what we have right now in green and what we need in purple? It's just that number 3 on the outside. So what can we do to get rid of that? Divide both sides by 3. So that'll give us x over 5 plus 1/2 equals 9 over 3, which is 3, and the answer for number 14 is B. Question 15 is an easy question dressed up as a difficult one because it's talking about exponential functions and it's giving us this graph that could look very intimidating to a lot of students. But what they're really asking us about is the idea that f of x really means y. So right here they're saying for what value of x is y equal to 0? And where do we see y equal to 0? Well, this is the y-axis right here. Where is 0 on the y-axis? Well, that's along this line here. Everywhere on that line, the y values are equal to 0. And right here, on the function itself, we've got y equal to 0 when x is negative 2. So for what value of x is y equal to 0? X equals negative 2, and that's C for number 15. Question number 16 is asking us about the difference between linear and exponential equations. A linear equation will usually be in the format of y equals mx plus b, and exponential will be in the format of y equals a times b to the x. But the real idea of a linear is that every time x increases by some number, we are adding something to y. So this chart here would represent a linear equation. The y's might be something like 10, 25, 40, 55, and 70. In other words, we're adding the same thing every time. So when you think of a linear equation, think about how something is being added each time. For an exponential, on the other hand, this is a situation where, yeah, we have an exponent in the equation itself, but what that means is that we're multiplying over and over again. So an exponential would look a little something like 2, 6, 18, 54, and 162. So in other words, we're multiplying by 3 every time here. So when you think of an exponential equation, think about the idea that we're multiplying every time we increase x by something. So what kind of equation do we have here? We have something that is being cut in half. It's being divided by 2 or multiplied by 1/2. So we know it's an exponential because every time this progresses, there's a multiplication that's going on. And it's getting smaller because if I'm getting half of something, I'm making it smaller. So it's a decreasing exponential equation, which is D for number 16. Question number 17 is quizzing us on the equation of a circle, which you definitely should know by heart. And the center of the circle is H and K, and the radius is the R. So in other words, it's the square root of whatever you see right here. So if we have a center of 0, 0, then it would be x minus 0 squared and y minus 0 squared. And if the radius is 2, then here we would have 2 squared. And that matches answer choice B for number 17. Question number 18 is giving us a nice factorable quadratic. And it involves BC factoring because there's a B term and a C term. What I mean by that is that a quadratic is in the format of ax squared plus bx plus c. So we have a B term and a C term. And for the a, we just have the invisible number 1. So that x squared there is really 1x squared. And when you have BC factoring, you're looking for two numbers that add to b and multiply to c. So here we want two numbers that add to 2 and multiply to -3. And what two numbers do that? That would be +3 and -1. They add to +2 and multiply to -3. X plus 3, x minus 1 equals 0, and that's how it factors. So now we can use the zero product rule, which is the idea that these two things are multiplying out to 0, and the only way that can happen is if one of them is 0, so we can just go ahead and set each individual one equal to 0, and we get -3 for one of the answers, and +1 for the other. In the first one, we were taking away 3 from both sides, and here we're adding 1 to both sides. So, if x equals -3, then x plus 3 is -3 plus 3, so it's 0. And if x equals 1, then x plus 3 is 1 plus 3, which is 4. So, x plus 3 is either 0 or 4. So our answer for 18 is C. Question number 19 is asking us about conditional probability. We're being asked about respondents who disagreed with the statement. So in other words, we're not being asked about the entire graph. We're being asked about these 548 people. And right here, we see their total. So the question is saying, out of that group of people, how many of them are at least 45 years old? And that would include these people here and these people here. Those are the ones who are at least 45 years old. So out of the 548, we're being asked about the 201 plus 102. In other words, the 303 of them. And 303 divided by 548 is 0.55 and some other random decimals. But the answer for 19 is D. Question number 20's got another XY table that didn't come through so well on this copy of the QAS. So let's just kind of rewrite it here. The X values are -1, 0, 1, and 2. And the Y values are 2k minus 2, 0, 2k plus 2, and 4k plus 4. So we're being told that this is a linear relationship, and that means we can find the slope by doing y2 minus y1 over x2 minus x1. So we can pick any two x or y values as long as we pick them in the same order. So let's go ahead and pick the easiest two that I can think of. Y2 minus y1 this way, and x2 minus x1 this way. So that would be 2k plus 2 minus 0, and 1 minus 0. So we just get 2k plus 2 over 1, which is 2k plus 2. And we already know that the y-intercept is 0 because the y-intercept is what you get when x is 0. So if we put this in as a y equals mx plus b, as I just said, the b is going to be 0, but the slope is going to be 2k plus 2, and that all goes in front of the x. And we're looking for whichever answer matches that. So maybe if we distribute this, we'll have y equals 2kx plus 2x. So we just took both of these terms and multiplied them against the x on the outside. And now, if we consider that there's a greatest common factor, both of these terms have a 2 and an x in them, so if we factor that out, we'll have 2x, and that leaves us with k plus 1, which is why it looks like this for our answer. Question 21 is asking us for a ratio of the mass of A to the mass of B. So for A, we have x, and for B, we have 1.1x. Well, they both have an x, so we can cancel them both away. We can divide both sides by x, just like we could in an equation. So if we do that on the left, we have 1.1, and on the right, it gives us the invisible 1 that's there in front of the x. So 1 to 1.1. None of the answers look that way, so let's just go ahead and get rid of this decimal here by multiplying it by 10. So we can make this an 11 now, and the other one becomes a 10. And the ratio is 10 to 11. Now, once again, we got there by multiplying both of these numbers by 10. Question 22 is asking us about the formula for the area of a prism. Now, first of all, what is a prism? It's when you have the same shape at opposite sides of a 3D figure, and they're stretched apart like an accordion. So here we have this blue triangle here, and this pink triangle, and they're identical to each other, and they're stretched apart like an accordion. So this is the h, the distance between the bases, and The volume is the area of the base. That's why we have a capital letter here, because it's an area multiplied by the height. So this question is very obviously directed at this formula. It's looking to see who knows it and who doesn't know it. The height is 12, and the volume is 96. So now we can just solve for the base, and 96 divided by 12 is 8. So the answer is 8, which is B for number 22. Question number 23 is asking us for the definition of standard deviation. Now, standard deviation, at least at the level of the SAT, is simply a measure of how spread apart the values are. So if something has values that are more spread apart, then it would have more standard deviation. Similarly, being less spread apart like this is going to be less standard deviation. So which of these has the smallest standard deviation? Absolutely answer choice D for number 23. Question 24 is an inequality word problem, and for any SAT word problem, if you're stuck, just describe your variables to yourself. X is the number of hours working as a teacher's assistant, and Y is the number of hours working as a private tutor. And we're being told that he's making $20 per hour when he works as a teacher's assistant. So 20x is literally the price times the quantity of what he receives when he's a teacher's assistant. And 25y is also the price times quantity of what he receives when he's working as a private tutor. So the question is telling us that all of this money has to be greater than or equal to 100 because he made at least 100, maybe even more than that. So the amount of money that he made has to be greater than or equal to 100. And that can be simplified. We can divide all of this by 5, and we would get 4x plus 5y is greater than or equal to 20, which is answer choice B for number 24. Question 25 is yet another word problem where we can benefit from describing our variables. We're being told that L is the length of one side of the floor in feet, and also that the C that we're being given is the total cost in dollars to tile the square floor. So we have C dollars and 16 somethings. We need to find out what that unit is, but we know that for the L, it's L feet, because that's what we're being told in blue there, and that's L feet squared. So if we kind of expand this out, the unit itself gets squared. So we have the L squared that you're seeing right here, but the unit attached to it also gets squared. So that's feet squared. And here we have the 16 and some unknown unit. The question is, which of the following represents the cost in dollars per square foot? Well, in order to have all of this stuff on the right work out to dollars, and it has to work out to dollars because what we're seeing on the left is that it's all equal to C dollars. It actually makes sense if this is dollars per feet squared, because if we were doing a unit conversion now, the feet squared would cancel with the feet squared, and we would be left with nothing more than dollars and dollars. And that's exactly what's going on here. So the feet squared can cancel there, and we have dollars and dollars. And so what is the cost in dollars per square foot? So through this process, we just proved that it's the 16 that is the dollars per square foot, and that's C for number 25. Question number 26 is asking us which of these graphs matches 3x plus 4y equals 16. And the way to make sense of this is x-intercepts and y-intercepts, because we know that for the x-intercept, that means that y is 0. For the y-intercept, that means that x is 0. So in our given equation, 3x plus 4y equals 16, when we want the y-intercept, which means that x is 0, that's going to give us 0 plus 4y equals 16. 4y is 16 divided by 4, and y is 4. But for the x-intercept, That means that y is 0, so that'll give us 3x plus 4 times 0 is 16. 3x is 16. And therefore x is 16 over 3, which is 5 1/3. So we're looking for y to be 4 when x is 0, and y to be 0 when x is 5 1/3. So we're looking for which graphs have the point 0, 4, and we see it right there. And that's pretty much the only place. So we already know, based only on the y-intercept, that it has to be A for number 26. Question 27 is a really interesting and trick question at the end of the day. So we're seeing that the cost is 5 billion, and the cost is the y in billions. So in terms of x and y values, this would just be the number 5. And we're also seeing that when the cost is 5 billion, the distance is 2,500, and the x value in thousands is the distance. So how many thousands do we have here? 2.5. So being aware of in millions and in thousands and in billions in this case is important, because we don't want to say here that x is 2,500 and y is 5 billion. In any case, it really doesn't matter, because we're talking about building something. The question is saying that each mile costs 2 million to build, and implied in that is the idea that when you haven't built any miles, so right around this point right here, there's been no cost to build so far. So what's the y-intercept of this? 0, 0. And we can go through a really complicated process of figuring out how many billions are in 2 million, and going ahead and doing the slope and using the point slope formula, and we would get 0 for the y-intercept. But this question seems to be designed to kind of spin our wheels a little and get us to do a lot of effort on something that's kind of pointless. If we haven't built anything, then therefore we haven't spent any money yet. So the answer for 27 is A. Now question 28 is kind of doing the same thing as 27. They're giving us the population in thousands. So for instance, if all of this is equal to 5, let's say, then it means that the population of Alaska was 5,000 at some point. And that is our y value, because the whole function, the y, these are both y's, those are the population in thousands. And x is the number of years since whatever date they're giving us there. So what is the predicted population of Alaska on that same date? So x is 0, because x is the number of days since January 1st, 1960, and they're asking us about January 1st, 1960. So that's the idea that x is 0, and it's Alaska, so it's this function right here, and we'll just plug in x is 0 right there. So 221 plus 9.78 times 0 is simply 221, but we do have to be careful because it's that many thousands. So this right here is a terrible decoy wrong answer, and the answer is D, 221,000. And now we're going over to number 29, where we're hearing about in what year does the population have to exceed 900,000. So this is the population of Hawaii, and it has to be greater than 900, not 900,000, because this is the population in thousands. And that same issue is what would cause you to have problems on both question 28 and 29. So setting that greater than 900, going through the steps here, we have 645 plus 14.5x greater than 900. Take away 645 from both sides, and we'll have 14.5x is greater than 255. Divide by 14.5, and x is greater than 17.6. So adding that to 1960, we're going to have 1977.6. So during the year 1977, halfway through that year to be exact, that's when the population first passes 900,000. So the answer for 29 is D. So question 30 is asking us about the basic exponential equation, and this is the idea. A would be the starting amount, B would be the way it changes, and x is the number of times But the big gimmick with this that the SAT likes to do is I could have a times b, let's say, to the x over 5, or y equals a times b to the 5x. So if we're dealing with years, this is saying that our same change is happening every 5 years. Just imagine plugging in 10 or 15. 10 would trigger this twice, 15 would trigger it 3 times. And the one on the right is saying that the change is happening 5 times every year. So we're either repeating or sort of stretching it out. Now, once again, imagine if I plugged in the number 3 here, this thing would get triggered 15 times, which makes sense if it's happening 5 times per year. So in hours, we know that it's decreasing by 30%. First of all, if you're decreasing by 30%, that actually means, well, increasing by 30% would be multiplying something by 1.3. But decreasing it by 30% means that we're going from 100 down to 70, and you'd be multiplying something by 0.7. So a decrease of 30% means multiplying something by 0.7. An increase of 30% means multiplying it by 1.3. So we have our 100 that we started at. It's decreasing by 30%, so 0.7. And it's happening every 3 seconds. So that's the idea of x over 3, just like this example here was every 5 years. So that's what we need, 100 times 0.7 to the x over 3, which is answer choice C for number 30. Question 31 is asking us to interpret a graph. How many more are classified as medium, large, or very large? So medium, large, and very large is these 3 green numbers added up, compared to very small or small, which are these 2. So the first number is just the sum of those 3 green numbers, which comes out to 8,739. And the next value is just the 2 blue numbers added up, which is 7,317. And so how many more is the idea of subtraction. So we're just going to subtract these 2 numbers, which gives us 1,422, and that's our answer for number 31. This right here should be a hint to us to use the quadratic formula, because that looks a lot like the quadratic formula. So our a is the invisible 1 in front of the x squared, our b is the negative 4 in front of the x, and our c is the negative 9, the constant at the end. So negative b is positive 4, plus or minus square root of b squared, negative 4 squared is 16, minus 4 times a, which is 1, times c, which is negative 9, all over 2 times 1. So 4 plus or minus square root of 16 plus, because here we have a negative times a negative, plus 36, all over 2. So that'll give us 4 plus or minus square root of 52 over 2. And so we've got everything we need. We've got it exactly in that format. The instinct is to actually simplify that 52. That would actually be something along the lines of 2 root 13. But that would change the format and kind of mess everything up. We already have a 2 on the bottom, which is what we want. So let's just leave that there. And according to that, M is the number 4 and K is the 52 because of the positions that they're in. And if you add them up, you get 56, and that's our answer for 32. For question 33, we need to know what does it mean to increase anything by 200%. And when we're applying a percent increase or decrease, we talked about it once before in this video already, you always start at 100, and if I'm going to add 200 to that, believe it or not, it leaves it at 300%, and if I'm going to take away 200, then that would be a negative number, so that's kind of irrelevant here. But in any case, 300% would be like multiplying something by 3.0. So this demonstration here in yellow is basically telling us that to increase 300 by 200%, that's the same as multiplying 300 by 3.0, which will give us 900, and that's our answer for number 33. Going over to question number 34 now, we know that this system has no solutions. We also know that these are both lines, and that's because x and y are to the first power. So you need to know that when x and y are to the first power, you're dealing with a line. When y is to the first power, x is to the second power, that's a quadratic. And when x is the exponent, that's an exponential. And those are the three main equation types you're going to see on the SAT. But if we're dealing with the number of ways that two lines can interact, we're talking about this, or this. So in other words, we can have one solution, no solutions, or infinite solutions if they actually ended up being the same lines. And if you have one solution, that means that the slopes are different. The y-intercepts could be the same or different in that situation. If you have no solutions, the slopes are the same, but the y-intercepts are different. And if you have infinite solutions, that means that the slopes and the y-intercepts are the same. So here, when they tell us that there's no solution, they're telegraphing to us that it's this situation, and that mathematically it means that the slopes have to be the same. So let's just take the two slopes, which I'm highlighting in purple, and demonstrate mathematically they're the same. So 3 over 2 equals k over 3. And for that, we can just cross multiply and solve. So k times 2 will equal 3 times 3. So 2k equals 9 divided by 2, and k is 9 over 2. And that's our answer for 34. It's either 9 over 2 or the decimal equivalent, which is 4.5. 35 is asking us about the idea of applying a percent increase or decrease, which we've talked about a couple of times in this video already. If I had 100%, let's just say, and I added 40% to that, I increase it by 40%, it goes to 140%, which would be the same as multiplying it by 1.4. But if I took away the 40%, then that would take me to 60%, which is 0.6. So multiplying something by 0.6 is the same as decreasing it by 40%. And that's exactly what happened here. It was multiplied by 0.6, which meant that it was decreased by 40%. So 0.6y represents the result of decreasing the quantity by what percent? By 40, and that's our answer for number 35. In question number 36, we're being told that the square root of a is equal to the cube root of b. And it's really important for you to know that the square root of a number is the same as that number to the 1/2 power, and the cube root of a number is the same as that number to the 1/3 power. So let's rewrite it that way. A to the 1/2 is the same as b to the 1/3. Now, here in green, we have another equation. A to the 2x minus 1 equals b to the 1. So how can we bring these both together? In my opinion, we can raise both of these to the 3rd power, and that'll give us a to the 3 over 2 equals b to the 1, which is really useful because we have b to the 1 here and here. And so if both of these things are equal to b to the 1, then they're equal to each other. So in other words, a to the 3 over 2 is equal to a to the 2x minus 1. So let's just write that out here. A to the 3 over 2 equals a to the 2x minus 1. And if the bases are the same, which they are, then that means that we're allowed to assume that the exponents are also the same. So 2x minus 1 equals 3 over 2, and we're just solving that now. Maybe multiply both sides by 2. 4x minus 2 equals 3. Add 2 to both sides. 4x equals 5. And divide by 4, and x equals 5 over 4. And that's our answer for number 36. Question 37 is giving us a chart and asking for the median number of delayed flights. So here are all the delayed flights, because that's what we're seeing in the key. It's telling us that all the darker bars relate to the delayed flights. And to get the median, you're putting them in order and picking the middle number. But if you have a graph, you can kind of just cross them out. So I'm going to cross off the biggest value and the smallest value. And now I'm going to cross off the next biggest value and the next smallest value. And so this one right here is the one that's in the middle. And it appears to be about 5,000. So we have 5,000, and that's our simple answer for number 37. Question 38 is saying for the airline with the greatest number of delayed flights, so the delayed flights are the darker bars, and so we're talking about airline B because the darkest bar there is the greatest. There, we're being asked what fraction of the total number of scheduled flights were delayed. So the total number of scheduled flights is right here, so that's 40,000. And how many were delayed? That's right here, which is 15,000. And so that's just 15,000 out of 40,000. We can divide them both by 1,000, so it's 15 over 40. Now we can divide them both by 5, and that's 3 over 8. And that's our answer for number 38. Thanks so much for watching our answer explanations for April 2021 SAT Section 4 Calculator Math. Grateful offers online SAT and ACT tutoring and also PSAT for students all around the world. If you're interested in finding out more how we can help you to pursue your best score on an upcoming test, feel free to reach out. Have a great day.